Class we started talking about terms of a circle, or parts of a circle. We said a circle is a set of all points in a plane that are given that are the same distance from the center. So if I have a circle, all of the points on my circle are the same distance from the center. We said this segment here is called the radius because it is the distance from the center to the edge of the circle. We said two circles are congruent if they have the same radius. We said a chord is a segment that has endpoints on the circle. And I said if the chord passes through the center, that makes it the longest chord, and it's called the diameter. And this is the diameter. We also said that if instead of a line segment, you have a line that passes through a circle, touches in two spots, what's that called? A secant. And if you have a line that just touches in one point, that was called a tangent. And this point here is called the point of tangency. If I have a shape, let's say, I don't know, this object here, and I have a circle inside of it. 1, 2, 3, 4, 5 sides, so this is a pentagon. I would say the circle is inscribed in the pentagon. Or I could say the pentagon circumscribes the circle. So circumscribe basically means that it's outside, and inscribe means that it's inside. So this is a quick review of what we talked about last class. We also discussed concentric. Concentric circles are like a dartboard. They have the same center. Concentric. All right, so that's our quick review from last notes. So today we're going to be discussing just tangent lines. So this line right here, this one, this guy, that's what we're going to be discussing today, tangent lines. And one of the theorems that we're going to discuss is kind of obvious. You can sort of tell just by looking. If I have a circle and I have a tangent line, and I draw a radius here. Here's my tangent line, here's my radius. What angle do you think the tangent line makes with the radius? Well, you are right if you said a 90-degree angle. So that's theorem 1. If a line is tangent to a circle, then it makes a 90-degree angle with the radius. And the opposite works too. Okay, we can flip the hypothesis and the conclusion today to this. If a line makes a 90-degree angle with the radius, then it's a tangent. So it works both ways. So as long as you see a tangent, you know this is 90 degrees. If you see 90 degrees, then you know that it's tangent. It works both ways. So let's look at some problems like that, because you can get some good problems out of this. So let's say I have a circle here, and I say AB is tangent to OA. AB is tangent to OA. Automatically you know that this is what kind of triangle? Well, you should say a right triangle. Now if I tell you this is 12 and this is 5, and I ask you what is the length of OB, you should know exactly what to do because you know you have a right triangle here. We've been doing right triangle stuff for a long time. So how do you solve for OB? Well, the Pythagorean theorem. 5 squared plus 12 squared equals c squared. So 25 plus 144 equals c squared. 25 plus 144 is 169. When we square root both sides, the square root of 169 is 13 and negative 13, but we only want to use the positive answer because we're talking about sides of a triangle here. So we know that C equals 13, or in this case OB. I should write OB. Ooh. Okay, OB equals 13. So those are the kinds of problems that you'll be seeing. Normally you do a lot of Pythagorean theorem with tangents because you're talking about right triangles. Now the next part happens when we look at two tangents to the same circle. And I like to call this the clown hat theorem because it looks like a clown hat. So if I have a circle and I make a tangent and another tangent, it's a bad drawing, but whatever, you get the idea. These segments are always going to be congruent. Congruent, congruent. Okay, looks like a clown with a little clown hat on. So if two segments intersect at a point here, and they're tangent to the circle, then the two segments are congruent. So I'm just going to write two segments are congruent. Easy, clown hat. Okay? So, for example, let's say I give you, here's a circle, here's a segment, here's a segment. I say this is x squared plus 18, and I say this is, let's make this minus. Oop. Minus 18, and I'll make this 7. And I want you to solve for x. Well, I know that these segments are congruent, okay, because they're both tangent here. So we get x squared minus 18 equals 7. If we add the 18, we get x squared equals 25. We square root, we get x equals 5 or negative 5. Notice that in this case, either one works, because when you substitute 5 or negative 5, it never gives you a negative length for the side. So you know that these both are solutions here. So we just get that by setting them equal. And last but not least for our notes, so if we have two tangents again, and here's the center, let's say I run a line through this point and into the center. What do you think that's doing to these angles up here? Well, it's cutting them in half. So I'm just going to say that the purple line bisects the big black angle up here. So a line through the center will bisect the angle. We don't need to get super fancy here. You just need to know that if you have a tangent and a tangent, they share this common point. If a line goes through it, it's going to bisect that angle. Example here. Let's see. Kind of an easy one, but you'll get the idea. Say I have this circle. Okay, and these are tangent. And here's the center. And let's say I tell you that the measure of this angle is 29 degrees. Now I want to know the measure of this big yellow angle. Okay, well, the measure of the yellow angle, let's call it angle, gives these some names, A, B, C, and we'll call this D. So measure of angle ABC equals what? Well, it has to equal 2 times 29. So what's 2 times 29? 58 degrees. All right, easy peasy. So those are the 3 things you need to know. First, a tangent line is always going to form a 90-degree angle with the radius. Second, if you have 2 tangents and they intersect, those 2 segments are going to be congruent. That's a clown hat theorem. I like to call it the clown hat. And then last but not least, if you have a segment that goes through the center and intersects this vertex up here, it's going to bisect that angle.